Hello and welcome to the eLab Innovation Podcast, the podcast on e-mobility for research and industry. My name is Simon Voss and I'm the Managing Director of eLab of RWTH Aachen. And today I'm delighted to welcome Klaus Hamacher, Director of New Business Development of BST, as well as Board Member of Battery Production at VDMA, here to the eLab Innovation Podcast. Together we want to talk about the current state of the art of inline process control, especially for battery production, and highlight the potential and challenges that are on the horizon. I'm looking forward to the conversation with Klaus and welcome him here at eLab.
But if we have a chance to mix the things, change the mindset, and I see this more in the younger generations, I have to say, that they have the more the culture to do things 80% first is enough. Yeah, and not
better done than perfect.
Exactly, and then do the next loop and the next loop to improve the things.
Klaus, welcome to the eLab Innovation Podcast. I'm happy to have you here.
Yeah, thank you for the invitation and thank you to be here. It's a pleasure for me. Thank you.
Thank you very much. All right. Today's topic is about battery production, but I think not limited to that, of course, and more specifically about inline process control. And what I would like to know from you is the current state of the art and the potential of the current state of the art, and of course also the challenges that we see in current production, because as you know, we all want to make batteries more sustainable and more cost efficient, right? To finally reduce also the price of electric vehicles and also stationary storage. And I think, the competences that you bring to the table have a meaningful impact on production cost and also the quality and traceability and all things of those sort. And we will hopefully dive into many of those points.
Great.
Before we do that, I would like to come to a more, let's say, personal note and understand what your path was and how you, what trajectory you took in order to make it into the field of battery production and become an expert on, especially also on the measurement technologies and inline process control. And maybe you can give us a little rundown of your path.
Yeah, okay. Thank you very much. Actually, I'm already in the web material processes industries and inline quality systems over 34 years.
Wow.
This is a long time. And
really,
the most time I was in the printing and packaging converting industry.
So printing of like newspapers and
packaging industry,
printing of packaging.
Okay. So if you look in Marktkauf or Lidl, or which is also international known,
sure,
all the packages. This is the main business, and we. I first started in '88 at the company Electromat, which belongs since 2014 to the BST group, and we have been only in the print industry. Yeah, and I started typically as a diploma engineer, in the focus on automation, and we start in the 90s the group of automation where I was the group leader, and I saw also that solution business is the key also to develop new products, new markets, or in that case, niches in the printing industry. So in the 2000s, I was then in the business more in strategic key account management, developing key customers. And as I said, in the year 2014, the merger from BST and Electromat comes together because BST is also in the printing and packaging industry, very active and also successful. And both together was really 1 on 1 is more than 2.
Yeah, nice. Emergence.
Yeah, and the good thing is, and there I was very excited, it was not only printing industry.
Yeah.
And because to run successful business, I think it's important that you have a chance to do diversification strategies in growing. That means you're not in one industry, you're in different industries. And I recognize that BST was also in the battery industry. And there I was very much interesting. What is this? And
I mean, back in the days, it was not as visible as now that it will become
Absolutely.
a big industry, right?
And I recognize they're already in this industry since 2000, but in China, and Japan, also in South Korea. So what I did is I booked immediately a ticket to go to China because I'm always interested in new things, to develop new things, because I always see chances. And I was not clear why this have not received this huge thing in the Western world, I have to say, specifically in Europe or in Germany. So I have a chance to see a lot of big players from today's point of view, like CATL, BYD, and all these, as you know, in China. And I was so impressed and say, why are we not doing this? And also, we in Germany say, you make battery, and we make printing, packaging, and non-woven and rubber and tire. These are the industries we are very successful. And I say, this will come over here very soon, and it was true. And then I make some researches, and then I recognize, this is also not an issue, or not an issue. It's a chance what we have here in Europe since 2014, when I recognized much before. And that was the point where I work out in 2-3 years later with the university, with the PEM, with your colleagues, business plan over with the workshop.
How to enter the battery field on a bigger scale.
Because for me, this was not a question to enter. It's just a question how fast we can do this and how fast I can convince the management.
Yeah, okay, got it.
and as you know, it's not a matter of the company. It's a matter of mindset, how to convince people to change, or maybe to do something on top.
I mean, back then it was, let's say, a long-term investment. Now it becomes clear because it pays off more quickly, but back then things were still unknown, and also the extent to which the European and German industry will shift towards, I mean, on the electric vehicles, to the electric vehicle market per se, but also on in terms of battery manufacturing. And we'll maybe also talk about fuel cell later, how relevant this market will become for Germany and Europe especially, right? Okay. So that was your entry into the field of electromobility, right?
You can, absolutely. And from that point, of course, the decision was made. Yes, we need to do something. It was clear. Make long story short, we also have been in some changes in the organization. That was a chance, and also to build up the strategically the new business development sector. So I'm now today global responsible for to develop the emerging markets like lithium battery, fuel cell, and also organic print electronics. And we have in total 10 subsidiaries, companies, where we have in each satellite, I have my guys, and not only guys, and also my staff there. They're also ladies or women, how to say, which are very competent. And we have make the right step here, I have to say. And today we are very successful already. What we see, the first fruits comes out, not only in Asia, and also now in Europe.
Before we dive more into the technology and in your innovations as such in more detail, you also have a second position, right, at VDMA. Maybe we can touch on this really briefly, that you could just give us a perspective what your role there is.
One thing is I learned very fast that you cannot do everything yourself. And I think one thing what I like very much is to do copy-paste. Because this is efficient. I like very much to do cross-industry technology transfer.
To frame it more positively, to build up on existing knowledge and competences.
So cross-industry technology transfer is for me some slogan I like very much, because why do develop the wheel again? And it was the same.
Cross-industry knowledge transfer. It could be a nice hashtag.
Yes.
I will note that down.
It's my sentence, I have to say.
It's cool.
As an entrepreneur, I would say if we can take one product 100% in the other product industry and always not really talking to each other. For this industry, it's an innovation. In this industry, this product is already 20, 30 years there. And I love these kind of things.
Yeah, to see synergies that can emerge.
Exactly. And here, the same thing when I was working with the PAM to work out with workshop, the business plan, coming back to your question.
Yes. So the PAM, the chair of RWTH,
exactly,
production engineering of e-mobility components, right?
There I have been also looking for how to increase the network. One thing is, as I said, university, like we are very close today working with you with guys together. And the other thing is how the German engineering association, VDMA, could help us. And I then joined.
You joined VDMA?
Personally, VDMA.
Yeah.
And in the battery production. And today I'm also a board member there. And I have to say, to be honest, one thing is from business point of view, it's very much helping. But I think it's also important.
The network that you build up, basically, right?
But also I see us BST and personally me as a must that we, or who should change the transformation to e-mobility. It's not the nurse, it's not the persons who serve the dinner and whatever. These are the engineers and technology companies.
Well, I think every person in every profession has its relevance. It's one big drivetrain, so to speak.
Yeah. But the key person are the technologies. Driver will be the engineers. And the technology companies.
They are at the forefront of the technological development, of course.
So I personally want to contribute to this transformation also. And I think this is also important to bring also some emotional things in here, because otherwise the things will not have the drive.
Yeah, of course. I mean, everyone has to wake up every morning and has an idea of why he or she is doing what she's doing, right?
And a good mix of these, I think, will drive the things forward, and that was what we are doing in. I like to do in the VDMA board, and our task is finally also the German mechanical engineering, the companies, machine manufacturers, to support them to best case to bring a platform for networking discussions. So we are working out some concepts. It's not only the annual meetings, also have workshops together with universities, with the machine suppliers, even also with the end users or the future end users, how we can bring them together. Because it's a huge challenge, because Asia is already ahead.
Yeah, of course.
But there is so much room and space what Asia cannot cover the potential.
We'll come to that.
Exactly.
Yes.
So
we talked about
we
this
try
already, right?
So we try, and I think we do it quite successful. But we can always do things better. And the VDMA, to give a voice to these machine builders in Europe, not only in Germany.
Okay, interesting. So the networking part, that people and professionals talk to another about different solutions and ideas, or idea solutions and further problems ahead. That's something that is also, from my perspective, very important. I mean, that's one of the main reasons why we started this podcast, because we said we need to connect industry, research, and everyone else involved to really foster innovation and bring forward, accelerate the transition of in the end, electromobility and what's beyond.
Yeah, absolutely.
Okay, so to really get going, we of course need machinery, production equipment that is efficient, that is reliable, and that delivers the quality to the extent that we need it, right? And I think that we kind of hover over and segue our way into today's topic, battery production and inline process control, right? To get a little bit more technical now. So let's first understand what is your focus area there. Hashtag roll to roll. Can we quickly describe what is the roll to roll process, And why is inline process control really important to master the discipline of roll-to-roll manufacturing?
Yeah, if we look, and I think we will come later to this again, but if you look first to the whole process to produce a battery, maybe these 18 or 20 process steps, and you have to see this as two categories. One is the roll-to-roll process, the web material process is a continuous process. And after the assembling process, I have pieces, and this is the discrete process. The right part is, so to say, well known to us already today. Yeah, module pack and how to put things together and
kind of the traditional automotive assembly line.
Absolutely.
Dealing with lots of pieces and by means of robots or also by hand assembling them into products. Yeah, sure.
So, and this is also our challenge now, and which is a chance. The process before the electronic production and the cell assembly processes, these are the roll-to-roll processes, starting with, mixing, let's take it in. So then we have the coating, we have the calendering, we have the slitting, then we have the notching or separating, and then we come to the assembly process.
So everything happens potentially on one line. You have a roller, you have another roller, and you unroll you unwind, and you wind the other. From a roll to a roll. So to speak.
So for each step I mentioned now has an unwind, a rewind. I take the reel to the next process, unwind, a rewind. So this is, let's say, something new now for the automotive industry, or let's say people have not worked with this. So we are coming more from the discrete process.
From different areas, as you mentioned earlier, right? You have the packaging industry where you have lots of non-woven textile, as you said, like foils, for example, that you have to print. So you have an unwinder and a rewinder there, kind of from an engineering point of view, kind of the same process, right? And now you apply this knowledge to another industry.
Yeah,
correct.
Cross-industry technology.
That's the hashtag.
And this is what exactly the thing is. And our challenge now is to bring over here the complete value chain, and this is what I said is the web material process. And that is the transformation and the challenge what we have now.
So the wet material that in the textile or in the packaging industry was the ink, right, for printing potentially. Is now the battery slurry.
Exactly.
Yes. Good. So the active material of the anode and cathode.
Exactly. So from that point of view, if you look with the helicopter on this, you cannot see the difference. Is it a printing machine or is it a coating machine? So first of all, the reel to reel, and this is the entrance. But if you look deeper, then you see, of course, the requirements. And now we come to the point also. I think we come to this also later. The requirements are not yet known, but let's take this as a later part. So the reel-to-reel process, why also is important to scale up mass production. Reel-to-reel is necessary. You can also take pieces, make slurry on next piece. But I think everybody can understand very fast. Reel-to-reel is a need, and because if you look to other industries. For example, liquid packaging, filling machines. I'm not sure if you know how the milk comes in the carton. There are different ways. You have the carton ready folded. You put the milk in piece by piece. There are very fast processes. But a lot of people do not know the fastest process is you have a web, and then you fold it to a tube. The tube is standing, and then there's a kind of another tube which bring the orange juice and the milk in, and inside the tube is then the liquid, and then you cut it
just
like this.
Cut it and seal it in the same time. At the same time, right?
And you come up to 8 liters per second.
Wow.
And this is if it's then liquid or is it chips or whatever food. So we can learn a lot from this industry.
Cross-industry knowledge transfer.
And if you look, I think it was 2020, Elon Musk showed already on his Tesla days. Look, on the video, say, look, the printing industry, the bottle industry, they show us how.
The canning, right, was also part of it.
Exactly, where you show the new size of battery. This is the way how we can scale up things. And this is not only valid for lithium battery, also for fuel cell. To produce GDL, CCM.
Yeah, so maybe we can, so to sum up the one part, so for battery manufacturing, roll-to-roll processes are especially important during electrode manufacturing, meaning manufacturing the anode, so the negative side, as well as the cathode, positive side of the electrodes, right? Before they get punched out or lasered into single sheets, etc. But that's the assemblies, right? So what you're opening now is, you say, okay, it's not just batteries that you can take your given knowledge from the packaging and printing industry to batteries, but you can also apply it to a fuel cell, as you say, right?
Absolutely.
Which is another relevant part of our industrial transition that we are under right now.
Exactly. So if you look to the production of, let's say, fuel cell components, so in the very beginning, then you have a PEM, you have to laminate the catalyst to get the CCM. But the position must be very correct, and this is the same thing what you do.
So catalyst-coated membrane?
Exactly.
So maybe to everyone who doesn't know.
You're right.
Yeah, because we're always talking in abbreviations, but I think it's important to just to highlight a little bit what we're talking specifically about.
And we have very similar challenges here. Always to look if the position is correct and corrected inside the process finally. And this is also one of the part here while we are sitting here, inline process control. So what is process control? Process control is the ability to monitor and adjust a production process to a desired output. And therefore you need this kind of closed loop systems. And this is what I explained. You need a sensor, this is the camera, then you need an actuator, and then you need a controller. And we want to make sure that the positions are exactly where they should be.
Yeah, and maybe to emphasize this, I think it's one thing, inline process control is one thing in a discrete process where you have a step-by-step process where you can theoretically pause in between or really adjust from bit to bit, right? But we're now focusing right now on roll-to-roll or reel-to-reel, as you could also say. And there, things are running continuously, right? And let's say a fault happens at a given time. When do you measure it, and how can you adjust while the whole thing is running? And I think that we have to emphasize. Yeah, that's a quite difficult discipline.
Yes.
And but please go further because I'm interested in understanding how you tackle this issue.
Is very good point. So let's imagine that we have these 5 process steps. If in this battery production, coming back to this one.
So starting with the coating, drying, calendering.
So let's take the coating application. So first of all, you have a roll-to-roll application. First of all, you need to get a material, in this case 10 micron, 6 micron foil, aluminium or copper, straight to the machine. And this is not so easy. And therefore you need automation.
So it's a very, very thin foil, right? It's like razor sharp, not razor blade sharp, but it's very thin.
So you do some process step in the coating, you do coating. You bring the slurry on the coating. You can imagine everybody, if the material is running like this, then the position is not correct. And to control a weakness of, let's say, a not running stable web is the wrong way. First of all, you need a straight running stable web in a production machine for a roll-to-roll. And therefore, you need simple functions like the right automation means drive system, tension control system. That's the first thing. Unwind and rewind it. I make sometimes also an example. So, for example, also you need also the web guiding. And the example here is if.
Can you explain web really quick? What does web mean?
Web
Maybe
is
give a quick definition.
Excuse me when I take this example, but in the morning or whenever you're on the toilet, you want to take the toilet paper and then suddenly it falls on the floor. And you will rewind it. Have you looked at the coil how it looks?
It's not perfectly winded anymore.
And this is why you need a web guiding system.
So the web means like the alignment of the roll, the substrate that is taken from the roll, that is taken in a desired manner, in a straight manner in this case.
Absolutely. And you need this for the unwinder, then you need this before the nozzle unit because you need a stable position there.
The slot die where you coat.
The slot die, and then you have a dryer, and then long dryer, then need to control again with the web guiding. The next layer B need to be coated, another web guiding, another rewind again. So there are several guiding systems. And each guiding system, now come to your point, your question, need a closed loop control. That the unwinder for itself makes sure that he is doing very stable everything. The next web guiding is after the web guiding is a sensor and do everything itself. Very good. Then you have the nozzle unit or slot eye, and then you put a slot on there. But still, you have an unobserved distance, let's say, from the last sensor.
That's where we lose the money. That's where things become expensive.
Exactly.
Yes.
So with other words, you have all these autark systems in the machine. In this case, we
separate from another in their controls.
And everybody do his job perfectly. It's like in the company. Everybody do this job. But we need to look from the complete thing. We need to talk each other. To add value more in the whole process to
synchronize to
For example, if for example the web guiding directly for the nozzle unit make sure that the position is correct, then afterwards I make a measurement of the position of the coating. For example, the edge from the base material with the copper, for example, to the coating should be 20 millimeters. If this is not the case, let's say a human would look there and say, oh, this is not correct, I will change the web guiding before.
Yeah, but until the time that it takes until someone looks at it, says to the machine operator, hey, we have to adjust the line, which is, by the way, running at up to, let's say, 100 meters per minute. Right, this faulty spot or the actual time when the fault occurs and the material that is produced with the fault will be already 20 meters ahead.
Exactly.
So 20 meters or let's say 30 or 40 meters of electrode will be wasted. And additionally to that, if you don't have a proper quality control management system that labels also and makes sure that people know and the operator knows where the faulty, because you don't see it by an eye. At one glance maybe, but you have to look a little bit more closely, then you really have a quality issue, right? And then the tolerance band, the quality band is higher, and then things down the line in the assembly, etc., could result in additional failures, right? That for example, the stamping or the cutting of the electrode is not perfectly in line anymore if you don't have a control system and a measurement system there. But that's discrete systems, as we said. Now we're talking about continuous. So my question to you is, how fast can we be? So we detect a failure, or a failure occurs, we detect it and we control. Well, how many meters are lost?
First of all, the target is not to lose anything. So if I look to the autark system, as I said, like let's take the web guiding. It doesn't matter. It could be a motor, it could be whatever, or tension controller. Let's say take the web guiding, and after the web guiding, I have the position of the sensor, and I have the closed loop system. We talk about milliseconds here. And these web guiding systems are running in machines with 1,200 meters per minute. So there is...
So that's not battery cell manufacturing.
This is
because everyone
flexible packaging slitting.
I'm just imagining everyone listening into this number right now and is familiar with battery manufacturing says like, okay, where can I invest? Where can I invest right now?
Speed is not the issue.
You're talking about 1,000 meters per minute.
Speed is not the issue. So the control system, the autark system, there's not a problem. Let's say if I look after the nozzle unit, the camera system is replacing, let's say, the operator who manually normally have to look, but he cannot look at 30 meters or 60 meters per minute, how accurate it is. So the camera takes this job. It takes the job. And if the camera say now deviations, then the camera is telling the web guiding, hey guy, you need to be a little bit on the left side, then my position is correct. Now you can imagine.
And and that's important to note, maybe, or not maybe, but certainly, that you detect this within a tolerance band.
Absolutely.
Before a failure occurs because you're out of range, right?
Yes.
I think that's very important to note.
Yeah, thank you. You can start working at our company.
We have our own pilot line here. I'm sorry.
Good. No, but the description is correct. You have the bandwidth. And so if we come to a position, let's say, we come in a critical care, or not in a critical, but in an area where it could be critical soon, then it's taking care that the web guiding is changing. Then we need to wait maybe the next 5 meters, and then he's looking again. So, and then this closed loop. So finally, there will not occur any defects, because predictive quality, you can say, or avoiding quality issues before they arise.
Yeah.
So this is the measure what you need to do. And that's why systems need to talk each other. Now I come to another example to make it clear for the
listener, watcher, viewer. We have both formats.
Now I say we have a 6-micron foil, for example.
Yeah.
You cannot take 10 millimeters guiding.
The foil will you get rib off. Yeah.
Rib off. It will be web break, or you get wrinkles. So if you come in a position where you need to move, for example, 1 millimeter, or 2 or 3, then the web guiding need to talk to the unwinder. Hey, the incoming error is too big for me. Can you move a little bit 2 millimeters to the left? Then I come back into my working positions. So you see now that this system need to talk
to another.
So, and this is the important thing, and this is the avoiding strategy for quality issues.
Got it. So a lot of communication needed, a lot of, as we say, or as we realize, data, right? You mentioned also visual inspection. In the end, this is also just data and information that needs to be processed. So I have 2 questions now. One is the importance of data and the whole management. And before we come to that point, because I think this has ripple effects up and downstream for the whole operation, not just for the product, but also for the operator of the facility itself, etc., etc. We'll come to that in a second. Before we dive into that, the cost-benefit ratio, because I mean, you were mentioning we were talking about our pipeline briefly. I know by firsthand, measurement equipment is expensive. It's important to have it, but it's also expensive. So it has to be a dedicated decision. Do we invest and implement a camera system, for example, inline quality control system, whatever respective technology it may be, and where's the threshold where we say, like, okay, it would be nice to know, but it's just too expensive and it doesn't pay off. I mean, it's hard to put numbers to it, precisely, but can we draw some thresholds where you say, okay, there's currently in the current state of the art a threshold where you say, okay, this is really adopted and almost required also from the customer, hashtag traceability of the cells in the manufacturing process. That has security issues or security aspects later in the product use when we install the cells in the respective electric vehicle. I think there is a big component there why you measure nowadays and why also OEMs want to measure, because they want to be able to trace back if there is a fault. Where you would say what current state of technology is used and what is becoming standard, and where you think like there is room for improvement. So just draw us a picture on where we are right now.
Wow.
Many questions.
Many questions. I know exactly what direction you asking for. Give me some more time now. Okay. I will try to answer this so that also everybody understand it. I mentioned now, let's say, the process control, let's say, in the coating line, so that the equipment is talking to each other, and that could be different equipments, not only web guiding, thickness measurement. You have all this measurement process data systems where make sure that the quality is okay. This we have in all the processes. Yeah. And now we talk, let's say, I call it vertical process, that is individual process itself. The good thing is we need to collect data. Because when I can collect data there, because they are there, because there are quality assurance systems there, or automation, drive system, whatever, they can provide temperature, everything. But now what we need here is position accurate data. Yeah. Because if the position accurate data is there, that means I need to know on each position, could be every 10 centimeters, what values I have there from the temperature, from the tension, from the position of the coating, from the thickness. If I can make sure this, then I have the chance to communicate this across the processes in a horizontal way.
Yes.
Yeah. Sounds very simple, but it isn't simple. Yeah. But first of all,
there's a lot of timing involved as well, right? You need to know how fast the machine is running, etc., etc.
Yeah. And when we have the same thing in the printing industry since 15 years. And you need to have a physical position there. Where's my zero position? Because you have stretching material after calendering. In flexible packaging, you're stretching material. It's the same thing. Then after the reel, you cut off material. Where's my starting point? It's lost. Yeah. So typical ways is maybe to put a QR code, for example, on the material where you can read and synchronize, let's say, every meter, and individually or between the meters you have then the absolute positions, and after this next QR code you already synchronized again, so if it's stretching or not relative, I know the position correct. And if I have this done in a data storage, then I can use this information for the next process. And what does it mean here? For example, if I found an agglomerate in the coating line, this could be damaging the drum in the calendar line.
So an agglomerate, kind of a cluster of particles, which has a certain hardness to it.
Absolutely.
Which can have downstream effects on the product, dendrite formation, etc., but also other harmful effects for, as you said, calendering process, which is basically like the compacting of electrode foil with a lot of force, a lot of line pressure, and then potentially damaging the rollers which are applying the force. Right.
So if I have the possibility to use these position accurate information for the calendar line, then I just open it. So far, of course, the calendar supplier will say it's not so easy.
You mark the spot where the fault occurs, and then you every process.
Yeah, but it's digital marked.
Yes.
So it's a digital information which I have in my data storage.
Well, they're both, right? You can print on the foil, but
and then you open the calendar line and close it. So in that case, you don't need a surface inspection in front of the calendar, which can do the same job.
Because you have measured it at a
exactly.
earlier point. Yeah.
And this is also what I mentioned in the last interview in the Battery News. Yes, inline quality assurance systems are now very important to put it in the machines today. But the first step is we, the battery industry, need it to learn. But in future, there will be a lot of consolidations and probably not used. And then we need, as soon as we understand better the process, and therefore I need also the position accurate data to understand the process. What happened and why I have, for example, a bending effect in the monocell, it's coming from the calendar. And then I learn on which position was it.
Maybe to put this a little bit in perspective, what you're pointing out there is, I think one very elegant point is to see, okay, we don't need to measure at every point everything, but you can measure at one point, and by synchronizing the whole roll-to-roll chain, okay, if I have a fault there, I have detected it, and I can deal with it also with the later processing steps.
Absolutely.
Because I have knowledge about an earlier processing step where it was detected. So I think that is the one thing, right?
And that has, coming back to your questions, this have an impact of return on investment for the equipment.
Because every sensor is cost.
And for example, if I have a defect where I know this part of the web is not to be used in the next process after, for example, assembly process, because after assembling I have the chance to kick it out. And I don't feed the process with material which is anyway not used. That will cost a lot of resources also.
Because the nature of the process itself is every step has to add value. That's why you're processing, right?
Exactly.
And that means vice versa, that if you have a fault, like a faulty range of material, let's say 10 meters of coated foil that is faulty, and you transfer it over to the next processing step and process it further, the cost, because you want to add value, you have to invest as like running costs for the machines, they will add up, right? And then you will put it to scrap after this processing, when you in the end measure, okay, the cell doesn't really work, so you dump dozens of cells. But if you can measure right at the spot, as you say, like detect it right at the spot, and at the next junction when you can operate, where you can make a decision, okay, let's remove this part of the roll, right? Then you mitigate further costs downstream.
Absolutely,
right?
Absolutely. This is one thing. This has an impact on return on investment. And therefore, it's sometimes, I would say in this case, very difficult to calculate the add value of whatever system. I only
it's a function of the quality that goes into the process also,
yes,
right?
and
How often you need it.
Yeah. I think sooner or later, I know this from the printing industry, when we start with print defect inspection system in the 90s, starting in the beginning of 90s, we have the same discussions, exactly the same thing.
Okay.
What is the return on investment? We do not know what is your pain, what are your production costs, what defects you want to see. And we have the same dialogue now with the end users. Important. The lithium battery industry need to explain us what defects do you want to see. And of course, they have the challenge. Actually, we do not know 100% now.
Yeah, yes.
So
yes.
first we need to learn. How can you learn with inline quality assurance systems?
Are we right now in a phase where we, you mentioned the word earlier, over-engineer, that we measure at more points that we potentially, theoretically, ideally need?
Yeah. But
and then we will later kind of correct the course to a level where we say, okay, now we know exactly where we need to measure.
Absolutely.
Okay.
Over-engineer is maybe too negative. I think
and
strategically.
You're right,
so
you're right.
we
it's
know
more strategical,
exactly.
very granular view on the
Yes.
process currently to really understand and to learn from a data perspective.
Yeah.
I mean, I can just talk from self-help at our pilot production line, where we also follow this strategy overall. Like, of course, expert knowledge is important, and that's crucial, but it has to build on a solid understanding of every parameter that is physically active or at play.
Absolutely.
And we are figuring out right now that we're also in a sorting process, right? And with every paper that is issued, etc., we understand more, okay, this measurement was needed, this maybe not, or not as important. And then we can make a hierarchy and rank them.
And if I go back now to the print industry, these end users come say, I want to have a print defect inspection for the process, flexo process review, and then we know exactly what their requirements are. Of course, they have a catalog of defects, if they have special products, what they want to print, but the discussion is very short. And today in the lithium battery, which is normal, the discussion is more the dialogue. Okay, what can we do the first step and the next step? How can we learn together? It's important. Machine supplier need to learn. First, lithium battery manufacturers.
Yeah, you're perfectly leading over to my next question.
Okay.
That is, because we are always looking up to now more from a technical perspective, where we say, okay, it's technologically needed or technical to understand physical parameters to adjust the process to deliver the quality in the end, and also potentially reduce costs, etc., and reduce the scrap rate. But I think there is a whole another and also emerging field why data and while inline process control can generate data and knowledge, more specifically knowledge, about the process and about the product that will be of use for later. And I'm talking about OEMs and battery, and if we're talking about battery safety. So can you talk about why is this important? What is the relevance of all of this measured data, this knowledge about the process and about the product for safety issues, and also we were talking about things in the direction of insurances and things of those sort. What can we bring to the table with inline process control there? So how can we feed that desire, and what is that desire? Maybe we can describe it really quick.
Yeah, quick. Okay.
Let's keep it.
Yeah. I think the headline also, or not only there are several headlines. One of them is all track and trace, and these kind of things. So let's come back to what I said. The disc rate process. We know exactly. The automotive industry knows exactly the parts have a QR code. They know all the things. So let's look on the web material process. There's a challenge. Where is the defect? Yeah? Where are the quality issues? So, but if I have position accurate quality data. Because I always say, the issue is not collecting data. You collect data, and then I ask a question, do you still understand your data? No.
Data is not knowledge, right?
No. So you need to know where are the data. So if there is one supplier who can be contacted from the lithium manufacturer, production manufacturer, please provide a position accurate data. For all quality assurance, automation, process, measurement systems, whatever. Yes. I don't care from whom it is, but I want to have one
You mean
data.
Who measuring technology supplier? You don't
But
care as an OEM, but you want to have it.
First, the lithium battery manufacturer. The lithium manufacturer.
Okay.
He need to make sure that
I was assuming now that the OEM manufactures his own cells, but you're right.
he will the next step. So first, the lithium battery manufacturer need position accurate data, and it doesn't matter which. He needed for one position for different systems, and there he need a supplier.
But why?
Yeah, because I can tell you, there's a lot of inline quality assurance system. If we talk about inline quality assurance, everybody promoting his track and trace system and whatever.
But why? The question, like what is in the end? Like why does everyone want to know what happens? I mean, we can answer this very bluntly, I think, because we see in the news cars catching fire, right? I mean, statistically, it's way less than the combustion engine, but people are afraid of this. Safety, ensuring the safety of the vehicle is an issue. And so...
What is the motivation to do this?
Yeah, exactly. Exactly. I just wanted to kind of rewind it like backwards to understand like where does this end and what do we need to do upstream in order to have the knowledge available downstream at the end of the manufacturing process.
I mean, one thing we already mentioned. First of all, one thing is I need data to improve my processes. First of all, we said we kick out things. This is one thing. If I have the position accurate data,
the other we can optimize the process. Yeah.
The other thing is I learn what's happening, so I can go backwards to the process. What happened there? I learned. The other thing is with all this digital data, I can generate a digital twin. I can simulate the complete process. But then I need really valid data. This is what I mean, not just data in the mass data, and I don't understand what is inside there. And
every model is just as good as the underlying physics are understood.
Right.
And that's
the other thing is also traceability. This is then interesting for the OEM.
Yeah, that's where we enter the safety issue, right?
Safety issue.
Where OEMs want to understand how safe, how well is the quality of our cells, and if there is a fault, can we assure that the manufacturing process was in line, right, within the tolerance band? And if yes, then the fault must be somewhere else, somewhere in the operation of the vehicle, for example.
The fourth or fifth thing is battery pass, which will come. It will be also contribute partly from this information, and also life cycle management, because also recycling. What is inside the battery? I need this information as well. And
sustainability point of view. Yes.
So to get data is so important, and this is also the strategic lever what we have here in I would say Europe or in the Western world, outside from Asia. To be competitive globally. And this is the only way how we can differentiate, let's say, to the Asian manufacturers.
Yeah, it's an interesting position that you have currently, right? Because in Asia, especially, there are a lot of manufacturing lines right now. The capacity is huge. And of course, they demand measuring technology as well, inline process control. So there's a customer market for you, right? And then we have the whole European and also American emerging, and also the rest of the world, of course, emerging markets, where you also see yourself delivering technology or your products too. Do you see differences in the markets and also from a customer and competitor perspective, right? Because at the one end, also the Asian market is your customer, but also, as I assume, your competitor to some extent. How do you see the dynamics in those different worlds, and where are or differentiate their requirements, for example? Do European manufacturers have different requirements on inline process control than Asian, for example? Or do they already try to leapfrog and see one step ahead? Maybe because currently we're a little bit behind, as everyone knows, hopefully. So is there a chance to really go one step more directly, or how would you describe it?
First of all, I have high respect about what the Asians are doing. I've seen, as I told you, quite a lot.
Yes. I mean, we can come back to your journey back to Asia when you understood right?
The requirements here in Europe are definitely very much focused on to be efficient. Efficient means I need on-spot quality, I need low scrap rate, so this is the driver already there. This was, let's say, 10, 20 years ago, when Asia started to produce batteries, not the focus. And I see this still also with the scrap rates. Let's say 3 years ago, I have not the chance to go to
during the COVID pandemic.
Of course, they will improve also. But we start immediately to focus on this, and this is the right way.
It's kind of in German or European, maybe to put it. I don't want to put stereotypes up here, but maybe also a little bit in the culture, right? That we discuss a lot, we plan a lot, we engineer a lot, and then we start.
But it's also dangerous. Yeah, again,
we lose time by that, right?
Yes, and you put the finger in the wound. And what this is a culture. This is not bad. It's just a culture. Each culture has
a different dynamic. That's why I was
absolutely.
asking. Yes.
But if we have a chance to mix the things, to change the mindset, and I see this more in the younger generations, I have to say, that they have the more the culture to do things 80% first is enough, and not
better done than perfect.
Exactly, and then go the next loop and the next loop to improve the things. We need to discuss things. We need to go through a lot of exercise. But one day we also need to say, let's try. We need more the culture like the US American, the failure culture. Yeah, let's make a mistake. It doesn't matter.
With Professor Kamka in our very first episode here, fail fast. Right?
Just exactly.
Don't hesitate to fail, because you will stand up again. And
nobody cut your head. No, it's true.
Yeah.
And the good thing is, and this we should not forget, if you make failures, you learn. You should learn finally. And this is important. Yeah. If you make tries, you learn. Yeah. And therefore, I think this is our challenge to get the right mixture. This is in line with what you said, over-engineering. We have talked about this also in VDMA and annual meetings, and but talk, but we need to just do it. And
exchange ideas and then get them get on the shop floor and try it out.
And therefore, I think it's my personal feeling. We should also not, as a German, always say, we're too slow and we are. It's in one way sometimes it's true, but the other side, if I look here and in other areas, there's a lot of things already happening. I think maybe we are not good in telling what we do good already.
Okay, interesting. So then let's get there really quick. Hashtag innovation and innovation strategies. When you say like, okay, let's try things out, let's get going. When you talk about your product generations and in the iterations that you go through, optimizing quality control systems for the transition, for the manufacturing, etc. What is the time frame there? So what are we talking about? If you say like, okay, let's try it, we have an idea, and it becomes a product. So how fast can we be?
Yeah. I don't want to just give a figure. Give me a little bit more,
a bit more room.
As usual.
But just trying to put in an order of magnitude. Like, is it like I think we can differentiate in two different things. One is an iterative optimization, let's say a software update or a facelift, so to speak, and the one is really a new product generation where you build up on new technologies. Where do you differentiate, and what are the timeframes roughly?
Yeah. So at BST we have implemented since several years innovation management, and we have just increased also the power there, and also the way how we differentiate the different innovation categories is, I would say, in 4 parts. The one is, as you mentioned, the iterative innovations, which is related to existing products, existing markets, upgrades, termination of parts. Then you need to get the life cycle managed. Then new functions and stuff like this. The other thing is the and this is something we do come to the question. Sorry, in 1 to 3 years sometimes. Yeah. Okay. So it's not too bad, I would say. If you go to let's say new markets, and what we do, we call it then architecture innovation. Then we need different technology, and in new markets, the target is to use existing technology.
I was going to ask,
exactly.
because you have two things, right? One is entering new markets with given technologies that you have, that kind of this cross-reference that we had, where you say like printing industry, going to battery industry, basically same technology.
Exactly, and this is the architectural innovation what we do.
Yeah.
That means from solution to product. That means we take our products where we see this could be used maybe to 80, 90, even to 100% in this different production process, but add value in. We need to add them with linking them together. For example, with, as I mentioned, they are communicating because the requirements are different in lithium battery. We need additional sensor. What we don't have, we put it as a solution in there. So time to market is very important. So we build something together, the architecture innovation.
Yeah, got it.
That could be less than 1 year, up to 5 years, even. Yeah?
Okay,
depends
really
but
case specific then.
The strategy is with solution business to cover time to market, and then you know exactly, okay, this is the solution what the market need, and from there we do the product to go in mass production. But we're already there.
Got it. Do you see the current transition, or the current involvement of all those different facilities, also gigafactories, etc., and that your iteration cycle, the speed that you're iterating new technology, that you're providing new innovation, is that faster or slower than the current buildup of new manufacturing technologies and facilities? We say it's in line. There's a rhythm between those. It fits, or would you say like, no, we are already ready. We are there. Just buy our equipment. You know what I mean?
Yeah, you need, of course, a kind of vision or forecast. You have to see what will come also. How to say? If I would say this was running perfectly, I would be in the wrong position. So I always see room that we need to improve. Yeah?
Yes.
But I have examples where in the battery industry where we have seen weaknesses, pain points, which, let's say, this industry even didn't put this in question. And we put it in question.
And why do you know? Or how do you know?
From the printing industry, because we do the things already 30, 20 years. And then we ask the question, why don't you make it this? Do you think this would help you? Oh, this is a good idea. And then you can ask, why is he not asking this? Yeah, what he do not know, you cannot ask. So we are the communicator between the industries.
You mean you cannot ask what you don't know, right?
Yeah.
Okay. You put it the other way around. No worries, I know what you mean.
Good that you are here. And therefore we are, let's say, the communicator between the industries. And then we come already with, let's say, the proposal or the solutions, and they say, oh, this is great. So this is more the technology push in the market, and not waiting, what do we need? What kind of problems do we have? Where are your pain points? And then go and develop.
It's valuable, yeah. And maybe that is a shout out to all also industries and also companies that are in a similar position, right? Where they have technologies at hand that maybe don't apply currently perfectly to the battery industry, but maybe if one looks a little bit closer, maybe a second time, one understands, oh wait, maybe we can.
And therefore you need to be open-minded and come out of your, I have to say, mental comfort zone.
Yeah, and that's where we also...
And allow everything,
yes,
cross-thinking.
And then exchange ideas as we're doing right now, right? And build up networks like your involvement in VDMA, like our eLab Innovation Network here that we are constantly building up and inviting everyone to join. And I think by that, we're in a good position to also take part in this thrilling race that we are in, right?
Absolutely.
Building new facilities and enabling the e-mobility of tomorrow. Klaus, thank you very much. It was a thrilling conversation.
Thank you.
Really happy to have had this discussion, and see you next time, I would say.
Simon, thank you very much, and thanks to your team.
Thank you.
Great platform here to be.
Okay.
Thank you.
Bye-bye.
Bye.